Hello everyone. Today we will begin the first module of this subject, embedded systems. So as we have seen in the introduction, in this subject there are two parts, that is in module 1 and module 2 we deal with the ARM microcontrollers, and in module 3, 4, 5 we deal with embedded systems. So coming to the first module, we have ARM 32-bit microcontroller. So in this we are going to study about a particular microcontroller, ARM Cortex M3. So before going into the details of ARM microcontroller, let us just have a look at the introduction of what is ARM, what is its historical background, and how the different ARM processors have evolved. So ARM is a 32-bit RISC instruction set architecture that is developed by ARM Holdings. That's the name of the company. So ARM actually stands for Advanced RISC Machine. So RISC, yeah, you know now what RISC means, right? It's reduced instruction set computing. So before it was named Advanced RISC Machine, it had the same name ARM, but it actually stood for Acorn RISC Machine. It's the name of the company that initially began this. So the ARM Cortex M3 that we are going to study, the 32-bit microcontroller that we are going to study, belongs to the Cortex M3 generation, Cortex generation of ARM processors, and particularly you are studying Cortex M3. That is one type among the ARM processors. It is the first of the Cortex generation of processors, which was released in 2006. Okay, among the Cortex generation, Cortex M3 was the first processor. It was primarily designed to target the 32-bit microcontroller market. So till then, whatever was prevailing was either 8-bit or 16-bit microcontrollers, and 32-bit microcontrollers were highly expensive at that time. So with the release of this ARM Cortex M3 and large-scale production of Cortex microprocessors, the 32-bit microcontrollers, more 32-bit microcontrollers came into the market with this ARM design. So this Cortex M3, particularly this particular processor, it provides excellent performance at low gate count and comes with many new features which were previously available only in high-end processors. So high computing facilities were available at a lower cost with the introduction of this Cortex M3 processor. So ARM, if you want to just have a look at the background of this ARM, it was formed in 1990, as early as 1990, as Advanced RISC Machine. It was a joint venture of three companies actually: Apple Computer, then Acorn Computer Group, and VLSI Technology. That's the name of the company. Okay, in the next year, that is in 1991, they introduced ARM6 processor family. So there are different versions of processor architecture. So ARM6 processor family was introduced in 1991. So the first company to get the license for this was VLSI Technology. So later on, other companies like Texas, NEC, ST, Microelectronics, Sharp, they all got license for these ARM processor designs. Then they extended the applications of ARM processors into different applications like your mobile phones, computer, hard disks, PDAs, home entertainment systems, and different products. Okay, so the speciality of this ARM is they do not manufacture the chips. Okay, they do not manufacture the processors or microcontrollers, or they do not sell the chips, or they do not make the chips and sell the chips. But what they do is they only make the designs. Okay, they make the processor designs and sell the license for that particular design to the business partners. So these business partners of this ARM are the semiconductor companies who get the license for these designs and manufacture the chips based on those designs. Okay, so based on the ARM low cost and power efficient processor designs, so these partners, which are the semiconductor companies, they create their processors or microcontrollers and system on chip solutions. So this kind of model, where you're not actually selling the physical product but only the design, that's called IP licensing. IP stands for intellectual property licensing. So along with the processor designs, which is part of IP, ARM also has some other kind of IP licensing, like systems level IP and various software IPs. So to support these products, this company ARM has developed a strong base of development tools. Okay, I mean the certain hardware and software products, debugging tools, or debugging and development tools to enable partners to develop their own products. So this is a basic layout, or we can just make out what is the difference between the processor and the microcontroller. You already know what is the difference between the microprocessor and the microcontroller. So what you can see is actually a chip, that is microcontroller unit, a microcontroller chip. You know, in a microcontroller, along with the processor, you have certain other things like, you know, memory, inbuilt memory, then IO ports, then other system, other things like, you know, maybe interrupts or certain peripherals, then clock and reset circuit, then the debug system. So all of them, along with the microprocessor, you know, they are inbuilt, they are there, you know, they are embedded on a single chip. So among this, you know, ARM actually makes the design. ARM only makes the design for the processor and certain peripherals. Okay, so you know what you can see is this Cortex M3 core, that is the processor actually, that is developed by ARM. The debug system which is required to debug that particular core, that is developed by ARM. Okay, then so the clock and reset things. Okay, so they are developed by ARM, or maybe some design houses or chip manufacturers. Okay, so the chip in turn, it is developed by chip manufacturers based on whatever the license they have obtained for the processor. Okay, so just a difference between the processor. Processor would be only the core, the Cortex M3 core, but along with that, if you have all other things, make it work as a computer, you know, it will become a microcontroller unit, MCU, or you can call microcontroller chip. So there are different versions of architecture in ARM. So before the advent of Cortex processors, whatever the processors or controllers we had in ARM, they come under classic processors. Okay. So then in Cortex, there are three different series: Cortex A series, Cortex R series, and Cortex M series. So these are some classic processors, you know, ARM7, ARM9, ARM11. So these were some variants before the advent of Cortex processors. So ARM7, it is an excellent workhorse processor. I mean, it has got good throughput, which is capable of wide array of applications. They are traditionally used in mobile phones, mobile handsets. Now, you know, they are also used in non-mobile applications. Okay, so ARM7, that's one series of classic processors. Then ARM9, there are again three processors in this. So ARM9, there is 968E, 946E, and 926E. Certain different variants. You know, 968E, it's the smallest and lowest for ARM9. That is built with certain interfaces for tightly coupled memory and aimed at real-time applications. This ARM9. Okay. So then ARM946, it's also real-time oriented processor with optional cache. Okay. A full memory protection unit and tightly coupled memory. Then another variant, 926E, is the entry point processor capable of supporting full operating systems. Like, you know, if you need OS-based embedded systems, you can use this 926, like Linux, Windows CE, Symbian, and different operating systems can be. They are supported by this 926EJ. Then the next version is ARM11. It has four different types of processors. ARM11 MP core. It was for multi-core technology, more than one core of processors, and it is still used in wide range of applications. Along with Cortex processors, this classic processors also that they are very much prevalent even now. Okay, so then 1176JZ. So it's the highest performance single core processor in the classic family. Okay, so it has it also introduced trust zone technology. That's one of the technology for security execution outside of the reach of malicious code. Okay, so it's for enhanced security in the system. Then one more variant, 560, 11562. So it's the highest performance processor in real-time classic ARM family. Okay, for real-time applications. Then one more thing is 1136J. It is similar to the previous one, I mean 926E, but it includes an extended pipeline and basic SIMD. We have studied what this SIMD means, right, in the fourth module. So it's single instruction, multiple data instructions, and also improved frequency and performance. So it's just a brief, you know, introduction of what were the previous processors before ARM Cortex, right? So here you can see different versions. This ARM7, okay, that actually comes under fourth version, version 4. Okay, so these are some features. ARM9, it comes under version 5. Then ARM11, that comes under version 6. And whatever the Cortex that we are going to study, that is under version 7. So in CSC also they have this ARM subject. I think for 4th semester they had. So they actually studied this ARM7 TDMM. It was version 4. But what you are studying is Cortex microcontroller. That comes under version 7. Okay. So it has different series or architecture profiles, we call them. One is profile A or A series, profile R, and profile M. Okay. So A stands for applications, R stands for real time, and M stands for microcontroller. So it is, cleverly given the name as ARM just to have the same thing as the name ARM. Okay. So here A series stands for applications, R stands for real time, and M for microcontrollers. So A, it's designed for high performance open application platforms. Okay. So wherever we need very high performance applications like mobile phones, so we use Cortex A series. And R stands for real time. So they are designed for high-end embedded systems where real-time, response is critical, time-critical response is required. So in which real-time performance is needed, right? Then M series, it is for deeply embedded microcontroller type systems. So they are actually low-cost devices which are used in normal microcontroller applications. So see, when we say ARM, it could be microprocessor or a microcontroller. Okay, whatever the designs we have, they could be for microprocessor or a microcontroller. So if you have other things along with the microprocessor on the same chip, it will become a microcontroller. So we will see these profiles one by one. A profile or ARM version 7A, that's particular series. They are used for high performance applications. So the application processors which are designed to handle complex applications, okay, so, such as high-end embedded operating systems like in your mobile phones, like Symbian, okay, so that was used in your Nokia phones, then Linux or Windows embedded systems, okay, so even your Android operating system you use, right, in your mobile phones. So so where an OS is used, OS-based embedded systems, there you can use this A profile Cortex processors. So these processors requiring the highest processing power and virtual memory system support with memory management units called MMUs, and optionally enhanced Java support and a secure program execution environment. So this ARM, it has also developed different technologies to support all these things. Okay, so example products for this that fall in this particular category or profile are high-end mobile phones, smartphones, okay, and electronic wallets for financial transactions. They are all certain examples for A profile. Then R, it stands for real time. So it's for real time high performance processors targeted primarily at the higher end of the real time market. So they are suitable for those applications like high end braking systems, okay, and hard drive controllers, and in which high processing power and high reliability are essential. Okay, you have studied what are real-time systems, right? Hard real-time, soft real-time, right? So in both of them, you can use this real-time or R profile of Cortex processors. Here, the low latency is very important. Okay, the latency, it cannot tolerate more latency. The time delay should be very less, and it should meet time-critical responses. And one more profile in this is M, that is targeted for low-cost applications in which processing efficiency is important, and cost, power consumption, low interrupt latency, and ease of use are critical, as well as industrial control applications, including real-time control systems. Okay, so they are basically for microcontroller units. So Cortex processor families are the first products developed on this version 7. Okay, and Cortex M3, which is the first one among the Cortex series, that is based on one profile of version 7 architecture called this M profile. Okay, so it's an architecture specification for microcontroller products. So this is a brief overview of the evolution of different processor architectures. You can see version 4, version 5, version 6, and the Cortex actually comes in version 7. Okay, so here uh, this Cortex M0, M1, they come in an intermediate one, version 6 in that M. Okay, so but actually Cortex M3 came first, and then Cortex M0 and M1 were developed. So as you can see, as the different versions have increased, the capability and performance are higher. Okay, so your ARM7 classic processors, they are in at the lower scale of capability and even performance. Then came ARM9 and ARM11. This is the scale of axis of capability, and this is the performance and functionality. What you can see, the application series or application profile, they have highest capability and highest performance or functionality. What you can see in this orange color, right? Application series or application profile. Cortex A5, A7, A8, A9, A15. So if you look at if you search for what processor is used in your mobile phones, it will be one of this. It will be Cortex A series of processors. Okay, so then at a lower capability and performance, we have Cortex M. Okay, M0, M1, M3, M4, all these different variants. Then in between there is real time Cortex R. There is again R4, R5, R7. Okay, this gives the same thing with the year here. Okay, the timeline of that, when what things came. First thing was ARM7, then ARM9, ARM11 that came into existence. Then the first M1 Cortex was ARM Cortex M3. Then actually M1, M0, M4, all others came. Okay, so later Cortex A series, R series, all were developed, and M series, they come under lower performance and functionality. Therefore, microcontroller applications. Then in between you have high performance real-time systems. Then at the highest performance, they give the high-end application processors. That is A series of that. Okay. So coming to the instruction set, or one special thing about the ARM processor's instruction set is there are two different instruction sets which are supported on the ARM processor. Okay, since this ARM7, okay, from ARM7 TDMI, that is from version 4, there are two different instruction sets. One is the ARM instruction set, another one is the thumb instruction set. Okay, thumb is actually a part of ARM instruction set. Okay, the ARM instructions are 32-bit wide, so they are 32-bit microcontrollers. So even the instructions or ARM instructions are 32-bit instructions. Okay, so just like thumb is a part of your arm, of your body, right? The thumb of your body is part of your arm. So they have named that part of arm as thumb, which are actually 16-bit instructions. So the ARM instructions are 32-bit instructions, whereas thumb instructions are 16-bit instructions. So why these thumb instructions are there is, sometimes, for certain tasks, for simple tasks, 32-bit instructions are not necessary. So even in such cases, if you use 32-bit instructions, the code becomes more lengthy. Okay, the code becomes more lengthy and it takes more memory. So that's why to perform some simple tasks, those instructions can be written in 16-bit. I mean, those instructions, for those instructions, we can use 16-bit instructions, and they can be mixed with these ARM instructions. Okay, so historically, what has happened before this Cortex processors is, so whenever there were two instruction sets used together, the state of the processor had to be switched from ARM state to thumb state, and from thumb state back to ARM state. Okay, so during program execution, the processor can be dynamically switched between ARM state and the thumb state to use either one of the instructions. And in the classic processors, the thumb instructions would not be mixed with ARM instructions. So the ARM instructions had to be written separately, and thumb instructions had to be written separately, and they had to be built separately. Okay, I mean there had to be state switching between the ARM state and the thumb state. The thumb, it provides only a subset of the ARM. Okay, the thumb instruction set, it provides only a subset of the ARM instructions, but it can provide higher code density because in a particular size of memory, more instructions can be there. Okay, so that's called tight memory coupling. Okay, so it is used for products with tight memory requirements, where we are required to use only a smaller memory with high code density. So as the architecture version has been updated, so more and more instructions have been added to both ARM instructions as well as thumb instructions. So in 2003, it was the year when ARM announced the Thumb 2 instruction set. So the kind of instruction set we have in Cortex M3 processors is the same Thumb 2 instruction set, which is a newer version or a new superset of Thumb instruction set, which contains both 16-bit as well as 32-bit instructions. Okay, so traditionally the Thumb instructions were only 16-bit, but this Thumb 2, a newer version of Thumb instructions, that contains both 16-bit as well as 32-bit instructions. Okay, so what you have to remember is this ARM Cortex M3 that always works in Thumb 2 mode or Thumb 2 state. Okay, so that has a combination of both 16-bit as well as 32-bit instructions, and they can be used together, unlike the traditional method where they had to be built separately and there had to be switching of the state from ARM state to Thumb state. Here, since we are operating only in Thumb 2, we can mix the 16-bit and 32-bit instructions, and they can be built together without state switching. Okay, so this Thumb 2 technology extended the Thumb instruction set architecture, that is Thumb ISA, into a highly efficient and powerful instruction set, okay, which delivers certain benefits in terms of ease of use, because you can mix them. Code size also reduces because you can use 16-bit along with the 2-bit instructions, and also the performance, obviously. Okay, the extended instruction set in Thumb 2 is a superset of the previous 16-bit Thumb instruction set, along with certain additional instructions of 16-bit as well as 32-bit instructions. So along with the previous 16-bit Thumb instructions, we have newer 16-bit instructions along with some 32-bit instructions. So it allows more complex operations to be carried out in the Thumb state. So earlier, in Thumb state, only some simple operations of 16-bit were carried out. But now, since this Thumb 2 contains both 16-bit and 32-bit instructions, even the complex operations are carried in the Thumb state itself. Okay, so thus allowing higher efficiency by reducing the number of status switching. The state switching is not there, in between the ARM state and Thumb state. So this actually shows the relationship between the Thumb instruction set, which are 16-bit, in the Thumb 2 technology and the traditional Thumb. So this is the traditional Thumb, which are 16-bit. Then there are Thumb 2 technology, okay, which includes both 16-bit and 32-bit Thumb instructions. And one particular superset of that, one particular group of those instructions are used by Cortex M3 processors. Okay, so there are more instructions in Thumb 2 instruction set. All the instructions are not supported by all the processors or controllers. Okay, so some certain instructions that fall in Thumb 2 technology, they are supported by Cortex M3 processor. Okay, and one part of that is the 16-bit instructions, but along with that we also have 32-bit and 16-bit Thumb instructions. So this Cortex M3 supports only the Thumb 2 instruction set. Thumb 2 and traditional Thumb. Thumb 2, it contains both 16-bit as well as 32-bit instructions. So instead of using ARM instructions for some operations, as in the case of traditional ARM processors, it uses Thumb 2 instruction set for all operations. So there is no ARM state in this case. There is only one state, that is the Thumb state, and that is the Thumb 2 state. Okay, so that's why this Cortex M3, it's not backward compatible with traditional ARM processors. Okay, not backward compatible means we cannot, once a system is built on this Cortex M3, you cannot replace it with the older versions. Okay, you can only replace with newer versions after ARM Cortex M3. So as we have support for both 16-bit and 32-bit instructions in the Thumb 2 instruction set, so there is no need to switch the processor between ARM state and Thumb state. ARM state means 32-bit, Thumb state means 16-bit. So you will always be in Thumb state only. In Thumb state itself, you can mix the 32-bit and 16-bit instructions without state switching. Okay, 32-bit instructions can be mixed with 16-bit instructions without switching the state, thereby getting higher code density and high performance with no extra complexity. For state switching, there are certain overheads, some timing constraints. Those are avoided in this by mixing them together. So the Thumb 2 instruction set is one of the very important feature of this version 7 architecture, the Cortex processors. So where do we use this Cortex M3? Basically, M series, they are used for microcontrollers. Okay, so these are certain applications. One thing is in low-cost microcontrollers. So they are the best suited processors for low-cost microcontrollers, which are commonly used in consumer products, from simple toys to certain electrical appliances. So it is a highly competitive market due to earlier, there were some 8-bit and 16-bit microcontrollers like 8051 and all, right? So there are too many competitors, but this provides a low-cost alternative to all that. Low cost and higher performance compared to 8-bit and 16-bit microcontrollers. So it's low power, high performance, and ease of use. These are the advantages. They enable the developers to migrate to these 32-bit systems and start using ARM instead of the traditional controllers. Then automotive is one of the application. In automotive domains, they have very high performance, efficiency, and low interrupt latency. They can also be used in real-time applications. So they support up to 240 external vectored interrupts, up to 240 different interrupts with a built-in interrupt controller. Okay, there is a built-in interrupt controller which we are going to see, nested vectored interrupt controller, NVIC. Okay, with nested interrupt supports. That means interrupt within an interrupt. That's called nested interrupts. And an optional MPU. MPU stands for the memory protection unit, making it ideal for highly integrated and cost-sensitive automotive applications in automobile industry. Then for data communications also we can use this M3 processors. The processors low power and high efficiency. These are the advantages. Okay, coupled with the instructions in thumb 2 for bit field manipulation. So there are certain operations which we are going to see. Okay. They make it ideal for many communication applications like Bluetooth and Zigbee. Then for industrial control also we can use in industrial control applications. The key factors are simplicity, fast response, and reliability. Okay, so all these are there in Cortex M3. So also there are certain interrupt features, low interrupt latency, and enhanced fault handling features. They enable this particular thing to be used in industrial control. And a wider market is consumer products. In many consumer products, a high performance microprocessor is used. Cortex M3, even though it's a small processor, it is highly efficient and low in power. It supports an MPU, memory protection unit, thereby enabling complex software to execute while providing robust memory protection. Okay. These are some applications. Low-cost microcontrollers in automotive industries, data communications, industrial control, and consumer products. Can list any of them. And there are certain advantages of these Cortex M3 processors. So they provide greater performance efficiency, means more work can be done, okay, without increasing the frequency or power requirements. Then low power consumption, and thereby most of the embedded products, they will be battery enabled devices, right? So the power consumption has to be very less. So this enables longer battery life, especially critical in portable products. Okay. Then enhanced determinism. So the guarantees that critical tasks and interrupts are serviced as quickly as possible and in a known number of cycles. This deterministic behavior, right? So then improved code density. Since it mixes the 16-bit and 32-bit instructions, it ensures that code fits in even the smallest memory footprints. Then ease of use. It provides easier programmability and debugging features, okay, for growing number of 8-bit and 16-bit users migrating to 32 bits. So earlier, they were using only 8-bit and 16-bit. Now, since you are migrating, it's not so much difficult to use. It's easy to use. Then lower cost solutions. It reduces the 32-bit based system costs close to those of legacy 8-bit and 16-bit devices. Okay, that means the cost is just the same as the 8-bit and 16-bit devices. So, when the textbook was written, they have mentioned that the 32-bit microcontrollers that costing only $1 at that particular time. It was costing only $1. So then also wide choice of development tools. There are so many development tools available for Cortex M3 or Cortex processors, from low cost or free compilers to full feature development suites from many development vendors. There are so many vendors who make development tools. Like we use Kyle Microvision. Okay, so the educational version is free, and it supports this Cortex M3 processors. So similar to that, there are many other development tools which can be used for this. Okay, so then we have the architecture of ARM Cortex M3. So this we will see in the next class. Okay. Today I just gave a brief introduction of the ARM processors and its background. Right? We just saw what is ARM. It's what are the different versions of the architecture, the classic processors, and the Cortex processors, right? So how they have evolved and how the performance has increased, and what the basic thing of the ARM Cortex M series of processors, that is the instruction sets, which has two types of instruction set: the ARM instruction set and thumb instruction set, right? And thumb 2, that is the special feature in, which has come from 2003, right? So that's thumb 2, wherein you can mix the 16-bit and 32-bit instructions without switching the states. And what you have to remember is the ARM Cortex processors, they always operate in thumb 2 state. Okay, so there is no state switching in between ARM and the thumb state. And also we have seen certain applications and advantages. So tomorrow we will start with the architecture. We will see what are the different blocks and what are the different components present in ARM Cortex M3 processor or controller.